Hello everyone, welcome to my channel. In this video we will be starting with the chapter Polynomials from class 10th. Okay, so you must have learned about polynomials in class 9, right? So let us revise polynomials. So this is an example of a polynomial because it contains coefficients, constants and variables, right? So this is a polynomial in terms of x. Now the degree of this polynomial is 1 because the highest power of the variable is 1, right? So the variable here is x and the highest power is 1, right? So therefore the degree of this polynomial is 1, right? Next, so this is another example of a polynomial. You can see this is a polynomial in variable y, and the degree of this polynomial is 2 because the highest power of the variable in this polynomial is 2, right? This is y raised to 2, this is y raised to 1, and this is y raised to 0. If there is a constant in the polynomial, that means it is multiplied to a variable, say x raised to 0. Okay, suppose I have 4x plus 3, that means 3 is multiplied to x raised to 0. 3 is multiplied to x raised to 0, and we know that x raised to 0 is 1, right? So in this case the degree of this polynomial is 2. Okay, so these are two examples of polynomials. Now we will see examples of non-polynomials. Okay, now you can see that this is an example of a non-polynomial because I can write this as x plus x is to minus 1, and you can see the power of this variable is negative number, right? For an expression to be a polynomial, the first condition is there are two conditions. The power of the variables should be whole numbers meaning 0, 1, 2, 3, right? If you see, the power of this variable is a whole number, but the power of this variable is an integer, right? It's not a whole number, so that's why this cannot be a polynomial. Okay, so let us see second example. Root x plus 2. Now root x plus 2 can be written as x is to half plus 2, right? Root x meaning x is to half, right? And you can see the power of this variable is half. So this is an example of a non-polynomial because power is not a whole number. Okay, I told you for an expression to be a polynomial, the power of the variable should be whole numbers. Whole numbers meaning 0, 1, 2, 3, like this, right? These are whole numbers, right? Which starts from 0, they are called whole numbers, right? We had seen earlier this example, 4x plus 3, the power is 1 and the power here is 0, right? This is not written because we know that x is to 0 is 1, no? So this is mostly ignored. So these are two examples of non-polynomials. If you want more examples of non-polynomials, we can see this. See, this is a non-polynomial y because I can write this as y raised to 1 by 3 y square. If you see, the power of this variable is 2 and power of this variable is not a whole number, it is a fraction. Okay, so if you have an expression where the powers of variables are fractions or negative numbers, then that expression cannot be called as a polynomial. For an expression to be a polynomial, what are the conditions? The variables should have whole numbers. Okay, if it was 4, then we can call this as a polynomial. Okay, because this is a whole number, right? But since there is a fraction here, I cannot call this as a polynomial, right? So therefore this is a non-polynomial. Okay, let us do different types of polynomial. We have linear polynomial. Okay, what is a linear polynomial? A polynomial which has degree 1, that will be called as linear polynomial. Okay, polynomial of degree 1. Okay, so examples. So this is an example of a polynomial. So all these are linear polynomials because the degree is 1 here. This is a polynomial in variable z and the degree is 1, right? Power is 1. Highest power in this is 1. Then this is a polynomial in degree y and the highest power is 1. This is a polynomial in degree 1, right? The highest power is this. And this is also 1. Okay. Next is a quadratic polynomial. So quadratic polynomial will be what? It will be a polynomial of degree 2. Okay. This quadratic, this name is derived from a word called quadrate. And quadrate means square. Okay. Okay, so that's why it is called quadratic polynomial. And so it's a polynomial of degree . So there are some, let us see some examples. Okay, all these three are examples of quadratic polynomial because power is, highest power in this is 2, highest power in this is 2, highest power in this is 2. This is a polynomial in variable u, this is a polynomial in variable y, and this is a polynomial in variable x. Next we have cubic polynomial. Okay, next we have cubic polynomial. So you can see that it's a polynomial of degree 3, right? So what are the examples? Examples. Okay, see these are 3 examples for cubic polynomial. You can see we have degree 3, here also degree 3, right? Okay, I forgot to tell you about the general form of a quadratic polynomial. Okay. Now this is the general form of a quadratic polynomial. Okay, ax square plus bx plus c, where a, b, c are real numbers, and the important condition is a cannot be 0, because if a is 0, this term will go, right? This term will disappear and you will be left with this, and this is a linear polynomial, right? And we don't want a linear polynomial, we want a quadratic polynomial. Quadratic polynomial means polynomial of degree 2. So to have a degree 2, a should be non-zero, a cannot be 0. Okay, so how we have general form for quadratic polynomial, same we have general form for cubic polynomial also. So a, b, c, d are all real numbers, and in the important condition a cannot be 0. Okay, a, b, c, d are real numbers and a cannot be 0. Why? Same reason. If a is 0, this term will disappear and you will be left with these terms, and that won't be a cubic polynomial, right? Because to be a cubic polynomial, the highest degree, the highest power should be present, right? And if this is not present, I cannot call this as a cubic polynomial. So this is a that is the reason why we are taking a, not 0. Okay, b, c, d can be 0. Okay, b, c, d can be 0. There is no restriction on that. Okay, here also b, c can be 0. Okay, because if this is 0, I still have a quadratic polynomial. If b, c 0, then I still have a quadratic polynomial. Here also if b, c, d 0, I still have a quadratic polynomial. But if these only is 0, that won't be a cubic polynomial, right? Okay, so yeah.